Hi everyone. Today we are diving into the top rounding mistakes student makes and how you can avoid or fix this mistake. You see, whether you are in school studying engineering or preparing for exams, rounding errors can cost you marks or mess up scientific measurement. Now, let's fix that today with clear explanations and challenging examples. So, what are the top mistakes that students are making when rounding? One of the top mistakes that students are making when rounding is rounding too early in multiple step calculations. When solving problem with multiple steps, rounding any number too early before the final step can introduce small errors that can grow throughout the calculations. You see, in engineering, mathematics, or physics, precision really matters, accuracy really matters. Rounding too soon can cause the final answer to deviate from the true value, especially in engineering tolerance, design, or scientific measurement. If we are asked to calculate 3.678 multiplied by 4.12 divided by 2.01. Now, the correct method of solving this problem is without rounding any value. So we'll be solving this arithmetic expression without rounding any of the values. So let's multiply 3.678 multiplied by 4.12. So by using our calculator, 3.678 multiplied by 4.12 will give us what? 15.15336. Now, so we now use the 15.15336 divided by 2.01. So using our calculator again, so we divide 15.15336 by 2.01. So we get this value, which now we are going to round this value to 2 decimal place. So if we round this value to 2 decimal place, our answer will be 7.54. That is, we round up to 2 decimal place. Now, let us look at the incorrect method. That is, we're going to round our values early before we start our calculation. So now let's change all the values early. That is, we round each of the values before we start solving this arithmetic expression. So let's round 3.678 to 1 decimal place, 3.7, and then we round 4.12 to 4.1, and we round the 2.01 to 2. Let's solve the arithmetic expression. So it will be 3.7 multiplied by 4.1 divided by 2. Let's multiply 3.7 multiply by 4.1. So when you use your calculator, 3.7 multiplied by 4.1, you get 15.17. So answer will be 15.17. We now use the 15.17 divided by 2. So we call our calculator. So 15.17 divided by 2, we get 7.585. 7.585. So when we round this 7.585 to 2 decimal place, it will give us 7.59, 2 decimal place. Now, if we compare this inaccurate value of 7.59 with our accurate value of 7.54, you see there will be an error of 0.05. That is, our error will be 7.9 minus 7.54. So our error will be 0.005. You see, this error might look quite small, but in engineering tolerance or circuit design, 0.05 can be critical. Imagine in civil engineering, you are calculating a load for a bridge. A 0.05 difference could mean structural failure. So, how do we go about avoiding or fixing this mistake of rounding too early? One of the ways we can fix this mistake is you keep full precision in all calculations. That is, you use all your decimal digits that your calculator gives you until the very end. Secondly, only round at the final step or answer, and round according to the significant figure, or according to the decimal place, or according to the engineering tolerance requirement. But remember, do all your calculations first, then round at the final step. This will definitely keep the accuracy intact throughout. The mistake number 2 that students are making when rounding is when they are rounding the wrong digit. You see, many students round the wrong digit because they misidentify place values, especially when dealing with decimals. It often happens when they are unsure which digit to round and which digit to look at when deciding whether to round up or round down. For example, when you are asked to round 6.7481 to 2 decimal place, so rounding to 2 decimal place means keeping the 2 digits after the decimal. That is, we'll be keeping 6.74, and the 7 is in the 10th place and the 4 is in the 100th place. So this 4 is the digit that we'll be rounding, and rounding this digit, the 100th place digit, which is the value number 4, will depend on the deciding digit, and the deciding digit is the number 8. Since 8 is greater than 5, what do? We round up. So we round the 4 to 5. So our correct answer will be 6.75. Now, you see, many students incorrectly round this value to 6.74. The reason why is that they may think that the 8 does not matter, and also they might confuse the second digit with the ones they should be checking, and some might just chop off the 8 and 1 and think, oh, they are not important. So this answer 6.74 is wrong. So the correct answer is 6.75. So how do you avoid of fixing this mistake of rounding the wrong digit? Is by always following this rule. What is the rule? When you are rounding to a certain number of decimal places, look one digit to the right of the place you are rounding to. Just like the last example we just did. The digit to the right of the place you are rounding to, that is your deciding digit. It will determine whether you are rounding up. If it's more than 5, you round up, or round down if it's less than 5. Another mistakes that students are making when rounding is many students misunderstood the trailing zeros. Many students or professionals drop trailing zeros without realizing that these zeros are critical in representing precision, accuracy, especially in fields like engineering, physics, and data science. For example, we look at when we compare a diameter measurement of 16.00 millimeter. When we compare it to 16 millimeter, what do you look at those values? What can you tell me about those values? 16.00 millimeter and 16 millimeter. Would you say both values are the same? No. Both values may look closely numerically, but they don't mean the same thing in engineering context. 16.00 is a 4 significant figures, while the 16 millimeter is what? A 2 significant figures. So when it comes to high precision, the 16.00 has a higher precision, and this 16 millimeter has a less precision. When it comes to engineering, a lesser precision. So 16.00 millimeter is not the same or is not equal to 16 millimeter. 16.00 millimeter is not equal or is not the same as 16 millimeter. So in practice, 16.00 millimeter tells engineers that this measurement is exact to what? To 2 decimal places, which is an indication of accuracy in design tolerance. Please, as engineers, how do you go about fixing this problem of misunderstanding the trailing zero? How do you avoid this problem? Because this small rounding mistake can change design specification, cause tolerance errors, and can even invalidate technical documentation. So how do we go about avoiding these problems? The golden rule is that you only drop trailing zero if the precision, if accuracy is not required, and you just want to use that value for estimation. So our final mistake that students are making when it comes to rounding is confusing decimal places with significant figures. While they both deal with the precision of a number, they are not the same thing. We know decimal place refers specifically to how many digits after the decimal place, and significant figures are those important digits starting from the first non-zero digit. So, for example, we are asked to round 0.004567 to 3 decimal place. So we'll be keeping the 3 digits after the decimal place. So first of all, we'll be keeping 0.004. Okay. Now we look at the digit next after 4, which is 5. So because 5, according to the rule, because 5 is equal to 5, what do? We round up. That is, we increase this 4, the rounding number, to 5. So our answer will be 0.05. That is, we just round these values to 3 decimal place. So what about the significant figures? Now let's round this same value to 3 significant figures. Let's round 0.00457 to 3 significant figures. Now, the 3 significant figures are the first 3 non-zero digits. So we are keeping 0.0456. Now, this is the number we'll be rounding to. And the number we'll be rounding to will not depend on the deciding digit. And the deciding digit will be 7. And since 7 is greater than 5, what do? We round up. So it means we increase our 6 by 1 to make it 7. So it becomes 6 will be increased by 1 to make it 7. So when we round to 3 significant figures, our answer will be 0.00.457. So we just round it to 3 significant figure. So how do we go about avoiding or fixing this mistake? Is to know the differences between decimal places and significant figures. Decimal places is the digit after the decimal point based on the position of the value. Then the significant figure is the total important digit, that is non-zero digit. If your instructor or project says round to 2 decimal places, please don't use significant figures and vice versa. A quick recap. So, in order for you to avoid making those top mistakes when rounding, don't round too early. 2, round the correct digit. Know the digit you are rounding to and the deciding digit. 3, don't drop important trailing zeros. And finally, know the differences between your decimal place and your significant figures. Thank you for watching my videos, and don't forget to like, subscribe, and check out my videos on rounding to decimal places and significant figures. Let's keep making math simple and powerful. See you in my next video.